are attempting the questions in rotational mechanics, we take the axis of rotation as center of mass or the point of contact. Like in this case, either we can take the axis of rotation over here, or generally it is taken over here, this point of contact, this center of mass. Now we have solved it using this center of mass as axis of rotation, and now we have found the value of A. Let's take this point P, which is stationary, there is no slippage between this and this, it's pure rolling. Let's solve this taking this as axis of rotation. Now if we take this P as axis of rotation and we find torque about this axis, so if this is point P, mg sin theta is acting this way. Mg sin theta is in this direction. So from here, normal reaction we are going in this direction, and mg cos theta is also acting in this direction. This is mg cos theta, this is normal reaction, and over here there is a frictional force. So if we take torque about P point, then this mg cos theta, that is mg cos theta, is passing through this axis only. So torque of mg cos theta about this is equal to 0. Similar torque of F about this point P is also equal to 0, because line of force is passing through this point only, axis only. Similar normal reaction torque about this is also equal to 0, because that line is also passing through this point only. That is the distance. That is the distance between the line of force and acceleration is 0. So the only torque is because of mg sin theta about point P, and that's why it rotates like this. If this is R, so torque of mg sin theta about P is going to be equal to mg sin theta into R, force into perpendicular distance between line of force and acceleration, that is R, is equal to I about P into alpha, right? So this comes out to be mg sin theta into R is equal to I about P is what? I about Cm plus Mr square. That is about this, about center of mass, ICM plus Mr square into alpha. So this comes out to be mg sin theta R is equal to ICM is what? Mk square plus Mr square into alpha, because there is no slippage between this and this. So A is equal to R alpha is very much applicable. That is alpha is equal to A by R we can write. So this can be written as A by R. So M and M, they get cancelled. So over here it comes out to be G sin theta into R is equal to K square plus R square into A by R, or A comes out to be G sin theta R square upon K square plus R square. This R goes over here. So G sin theta into R square, this goes in the denominator, that is K square plus R square. We can take this R square over here. So that comes out to be G sin theta. This goes below this, that is K square upon R square plus R square by R square is going to be equal to 1. We get the same answer. That is A is equal to G sin theta over 1 plus K square upon R square. Whether you take this as axis of rotation or you take this axis of rotation, if you take this as axis of rotation, I will be only about this axis. If you take about this, then I is about this axis. And using A is equal to R alpha, we find that is the same answer we get. Now let's do it on the basis of conservation of mechanical energy.